Okay, I guess Dr. Debasish Das is with us.
Yes. Hello, Bisam.
Yeah, welcome, sir. So I hope the stage is yours, and we have already started our first session. It was a very fruitful session. Hope our participants will learn lots of things from your session. What do you say?
Okay. Thank you, Bisam sir. Thank you for the invitation. Okay. So, should I start?
Yes, sir.
Okay. Sure. Okay. I'll share my presentation. Okay. The presentation is visible. Dr.
Yes, it's
Bishamka? Yes. Okay. Okay. So, good afternoon, all of you. So, I'm Dr. Debasish Das from IIT Jodhpur. Okay. So, this is
Excuse me, sir.
a.
I'm just interrupting you. The presentation is not visible yet. It was coming, but now it's going.
Okay. Now it is visible.
Yeah, now it's coming.
Okay. Okay. So this is the topic. Okay. So online trip recommendation system for road safety based on the driver stress and driving behavior. Okay. Basically the recommendation system. Okay. And based on the machine learning. Okay. And here our objective is somehow calculate the driver stress, and based on the driver stress, our objective is basically calculate the driving behavior, and from the behavior objective is somehow identify the means positive behavior or negative behavior, like this type of application. Okay. So this is a basically in general topic. Okay, so I'm basically from IIT Jodhpur. So these are our small department, CSC department with the large number of faculties. Okay, and here the area of specialization, and some of this work already published in IEEE transaction in my paper. Okay, so related paper. And now, so this is the basically a smart city application. So here our objective is on the one important pillar, smart transportation, and in the transportation there is our objective here, the intelligent transportation system. This application is related to the intelligent transportation system. Basically this application is related to our Ola and Uber service. Okay, so sometimes what is the problem, because in the Ola and Uber, sometimes the driver have the more stress. Okay, but they want to continue their service. Okay, so that's why there is a possibility there is a possibility for the accident. There is a possibility for some other component as well, environmental effect as well. Okay, so that's why our objective is somehow when the driver stress level is too high. Okay, so then we'll send some message to the Ola and Uber service, means basically the control center. Okay, they are responsible for the they check what is the stress level of the specific driver. Okay, then based on this stress level, they decided he will continue with the next trip, or they want to close his service. Okay, so this is the in general concept. Okay, in this case, what is the benefit? In this case, benefit is basically stress-free driving. Okay, and as well as a comfort driving. Safety related application means basically there is no accident. Okay, as well as also increase the recommendation in the case of Ola and Uber. Okay, and financially the both driver as well as the service provider both are benefited. Okay, so this is the basically in general concept, and this is related to the smart transportation system and main focus on the intelligent transportation system. So I'll explain the in details the what is the exactly. Okay, so this is the basically trip recommendation system. So what is the means motivation for this work? The global status report on the road safety, okay, so by the WHO in the December, and is in the highlight that the number of the annual road accident death is reached up to 13.5 lakhs. Okay, so number of road accident day by day increasing. One of the reason of the road accident is significantly the basically significantly discrepancy between the growth of the transportation sector as well as the availability system to make and the eco-friendly and safe, cheaper and comfortable drive. Okay, so that there is a mismatch between the growing traffic volume, okay, and availability structure, okay, availability our infrastructure. Okay, so there is a big mismatch. So that's why there is a possibility the accident and traffic jam as well. Okay, so the rationale of this mismatch is on the faster because the mismatch is due to the our faster evaluation of our society, okay, our economy, lack of the driver training institute, and multiple more reasons are there. Okay, and so we think that this inconsistency will pursue to grow and as well as the affect the our society. Okay, so then what is the solution? So in this case, solution is basically the some intelligent concept or intelligent algorithm, okay, based on the machine learning or deep learning, which is basically responsible for resolve this issue. Okay, so intelligent algorithm or solution is required. Okay, so in this case we identified the transportation sector and basically the cab services, okay, cab companies. Okay, so we can apply the same concept for the insurance company, same concept for the other application also. Okay, so here we specifically identified the transportation sector, and in the transportation we also identify the this thing the some cab services or basically the Ola Uber service. Okay, so any doubts? Okay, if no doubts, then I'll continue. Okay, so then so the transportation sector provides the more opportunity to choose the cab companies like the either Uber in our country, Uber and Ola. Okay, and Grab is then the for international service, Uber also the international service. Okay, for attractive income option to the driver. So what is the problem here? Our main concentration on the three things. One is on the Ola and Uber services, and second one is on the driver, and third one is on the specific service provider. Okay, and this is related to the basically the basically transportation sector. Okay, so to choose the cab companies like the Ola, Uber, and for attractive option is on the attractive income option to the driver. Okay, so attractive income option means if you cover the multiple drive, okay, multiple trips, okay, as well as the distance also more. Okay, so then there is a possibility income also too high. Okay, so that's why the to demand for the taxi services, and we know the now the demand for the taxi services is increasing by the nowadays, and service provider companies like the Ola, Uber identify a significant market for this sector. Okay, because every state as well as every city have these services, Ola, Uber services. Okay, now what is the problem? To earn the more profit, okay, and companies offer the high incentive to the driver for the completion of the mode trip. Okay, so this is the problem. Okay, this is the problem to earn the more profit, because those companies, private companies basically in general, okay, Ola, Uber services, so they want the more profit. Okay, and so that's why more profit purpose they want also the companies offer the high incentive to the driver, okay, for completing the mode trip. So driver also interested to complete the for the attractive income purpose, they also complete the more and more trips. Okay, but but it is okay, but somehow what is the problem? Problem is due to this, there is a possibility large number of accidents. Okay, large number of means basically large number of accident and more fuel consumption and multiple parameters as well. But we are focusing on the basically the accidents. Okay, so how to reduce the accident, because our main motivation is on the WHO report. Okay, so now the problem arises. What is the problem? Problem is related to this point, third point. Okay, the problem is arise when the driver take a long hour drive or more number of trips while the ignoring the physical and stress level of the condition for the high payment. Okay, so ignoring the his physical and stress level condition, okay, for high payments. Okay, so this is the problem. Okay, if the stress is high, there is a possibility it will affect to the his driving pattern. Okay, so this is the basically problem. Okay, so the problem statement is clear. The to earn the more profit, companies offer the high incentive to the driver, okay, for completing of the more trips or the long hour journey. Okay, but driver also follow the same thing, long hour journey, and ignoring the physical and stress level for the high payment. So due to this, there is a possibility the accident will occur. Okay, so now if the accident will occur, then what is the problem? Problem is the total loss. Okay, loss for the insurance companies, car companies, okay, as well as the loss for the Ola Uber service. Basically, main loss in this case, the Ola Uber services as well as the driver. Okay, so with this increasing demand of the services, it is important for service provider to provide the service. Okay, now the fulfill the high demand of the services, so they want to basically they want the all service provider want the more profit. Okay, but also they want to satisfy the recommendation or basically the high rating services. Okay, then the some peoples want to select the like Ola or Uber. Okay, to fulfill the higher demand of the service provider. Okay, so this is the basically the objective. Okay, and they also continue to then the complete the more and more trips. Okay, otherwise if the more trips means more benefit. Okay, so it increasing the stress level. So if the more trips means there is a possibility increase the stress level of the taxi driver as well as the health. Okay, and high stress level is on the abnormal driving behavior. Now we establish the relationship here. If stress level is too high, okay, so then the his behavior is abnormal behavior, and if the abnormal behavior, there is a possibility it is under there the possibility cause for the road accident. Okay, now the problem statement is clear. Any doubts, any query from the audience? Any doubts? Or you can write in the chat box as well.
Anybody having any doubts?
Any doubts? Again, I'll repeat, no issue. Okay. Okay, so simple concept means all companies want the basically more profit. So that's why they are the basically focusing on the more trips. Okay, and long hour journey. Okay, and driver also interested for completion this long hour journey as well as the large number of trips for their income, extra income. Okay, and but the problem is they are ignoring the stress and physical level. Okay, so that's why there is a possibility, and they're due to the stress, their behavior is not the like the normal behavior, it is abnormal behavior. So that's why there is a possibility of accident. Okay, so due to the stress, so if the accident will occur, then the loss for the companies as well as the loss for the driver as well as the degrade their performance of the society, means basically their team. Okay, so that's why that they are also very careful. Okay, all taxi companies also the careful how to reduce this thing. Okay, so that's why we'll provide the one system, which system is responsible for calculating. System means basically IoT based system. Okay, we'll design and we'll implement it, and we collected the some information related to the driver behavior, and from the driver we collected the information related to the driver stress, and from the stress we identify the what will be the driver behavior. If the driver behavior is okay, then we'll recommend for the trip. If driver behavior is not up to the mark, then we'll recommend the trip to the other driver. Okay, and send the alert message to the reject option with the reject option. So your stress level is too high, so you can improve your stress level, then there is a possibility you receive the next trip related information. Otherwise you are currently you are not receive the any information, okay, due to the your stress level is high. Okay, so like this way Ola and Uber can maintain their services, okay, as well as the no accident and no market risks. Okay, so relationship. So here we establish the relationship. So first we calculate the stress related information based on our device. Then from the stress we calculate the behavior. Okay, so if the stress is too high, then his behavior pattern is not normal, something different. Okay, when initially during the when he started his journey, then his behavior is different. Now his behavior is totally different. Okay, so that's why. So driving stress and behavior relationship between the, we establish the relationship between the driver stress as well as the driving behavior. Okay, and if the stress is too high, so then the behavior condition is totally different. Okay, now what is the stress? So stress is basically the stress is the response of the brain and the body to any demand. Stress is a major concern in our daily life, and it implies the significant health and economic cost to the society for the every. Stress and driving are the dangerous combination. Okay, then the have the following consequences. If the stress level is directly related to the driving behavior, okay, and stress result is poor driving quality and accident in the sum of the causes. Okay, if the stress is too high, then there is a possibility it will directly related to the behavior, and behavior is totally changed, not like the normal behavior, and there is a possibility for the accident. Okay, so this is this diagram. It says this, and stress level is too high, then there is a possibility of accident. Okay, in the previous figure also the due to the stress level there is a possibility for this type of scenario occur, this type of scenario. Okay, but this driver is very okay, this driver is under basically due to the high stress, his decision making thing is under very slow or something. Okay, then here also this type of scenario will occur. Okay, and finally there is a possibility due to the high stress accident. Okay, so here this is under due to the high stress. So our objective is somehow calculate the stress level of the driver. Okay, and then it is related to the driving behavior. If sometime it is possible that his driving behavior his driver stress level is too high, but his behavior is still okay, because that's why we want to calculate the behavior, because different person have the different capability or capacity for his stress level. Okay, my stress level is too low and Bishankar's stress level is too high. Okay, so there is a possibility. Okay, so multiple person, they have the different stress level, and they can also follow their behavior pattern, okay, differently. Okay, so now here the relationship between the driver stress and driving behavior. Okay, so here these are what are the behavior. If the driver stress level is high, then the following effect will be occur. Okay, so these are so from this figure If his stress level is too high, then this scenario will occur, and this will the basically behavior pattern of the driver. Okay, so what are the possible thing? Speed profile is sometimes the too high, okay, sometimes too low, or multiple thing. Okay, speed profile, it will affect the speed profile, interaction with the speed breaker. Okay, speed breaker, multiple time he will press the brake or something. Okay, then the sudden and sharp jerk, a sharp U-turn, okay, sudden brake. So these, in this scenario, his behavior due to the stress level, his behavior will not like the normal behavior. Okay, so we have identified the sum of the scenario. You can identify the more. If you want to identify the more scenario or more like this type of event, okay, so then there is a possibility your system is more accurate. Okay, so we have identified the sum of this. Okay, now we, our objective is driver stress assessment system, which is responsible for calculate the driver based on this parameter, help to us the calculate the stress level of the driver, so then the road safety will not be compromised. Okay, so we, our objective is, based on the first objective is a driver stress assessment system, implement the one driver stress assessment system, which is basically follow the this following condition. Okay, as well as the calculate the stress level of the driver. Okay, and for the road safety. Now, stress is in the state in which the human behave the differently than their the normal behavior. Okay, so problem statement is, first we are focusing on the stress. So main concern is stress. Stress is a state in which the human behavior is differently than the normal behavior. And during the driving, stress may lead to the behavior. Okay, if the stress, because we now, our objective is somehow establish the relationship between the stress and behavior. Okay, so that's why the we identified this thing. Stress may lead to be a behavior. That result will the dangerous driving, and worst case it may lead to another accident. Okay. Now, what is the contribution? Contribution in this case, basically the, we want to design the one system, which is the intelligence system for the road safety of the driver as well as the passenger. Okay, and that is calculate the driver stress and recommended or not recommended to take the next ride. Okay, so from the stress we can calculate the behavior, and finally we recommend or not recommend the next trip. So if the Ola, Uber and other Grab companies, they service provider, they want the this type of system, so in their case the profit is also too high, no compromise. Okay, but their case basically only the, they have to identify the stress level of the driver, and they also identify the what will be the, how to transfer the trip from the one driver to another driver. Okay, this is the, this system only only responsible for reduce the, not only the profit as well as the reduce the number of accident. Okay, which is basically important for our society. Okay, now, so what is the objective? Objective is calculate the stress level of the ride art. So current ride, okay, current ride wise we want to calculate the stress level of the rider. Okay, and estimate the behavior of the driver on ride R+1. Okay, so based on the this current stress level, we estimate the behavior of the driver for R+1. Okay, and depending on the current stress level. So based on the current stress level, we also estimate the behavior of the driver and suggest the driver is accept that okay, will driver will responsible for continue the trip, or we can, service provider can accept the trip, or service provider can reject the trip, or service provider can means accept or reject the trip and also send the some information. Your, like in the case of he's accepted the trip and he mentioned that your stress level is too high. Okay, like this type of information. He's rejected the trip. He also mentioned that your stress level is and the lesser than the threshold. Oh yeah, means just above the threshold of the stress level. Okay, so if you reduce the stress level, then you are eligible for the next trip, otherwise not. Okay, so like this type of information, and provide the suggestion of the next trip about the speed limit, or I mean this is the alert message basically. Okay, Okay, so it's clear. Objective is first we calculate the stress level of the current drive, then we behavior for the next. Okay, and finally we suggest the either accept, reject, or in between the trip, and based on the some alert message. Okay. Now here we are using the different methodology. Okay, so first methodology is and to calculate the stress and behavior and establish the relationship. Okay, so establish the relationship between them. Okay, then second one is on the design the efficient communication scheme through the VANET and VEC. Okay, now after this we can using the some efficient communication purpose. Okay, so some scheme using the vehicular ad hoc network and using the vehicular edge computing. And third one is on the we also using the distributed framework for integration of the prediction model. Okay, and accept, reject, or compromise the trip. Okay, so first objective is on the important. These two things is on basically the communication related as well as the recommendation related. But main thing is in this one. If we calculate this one, then we can communicate. We can finally take the decision. It is accept, reject, and we can use the distributed environment. Okay, centralized means so in general architecture of the service provider in number of customer. Okay, want to book their cab services either through the Ola app or Uber app. Okay, and then the service provider directly send the specific car within the region. Okay, now so here what is our objective? Our objective is basically here trip related information. Our objective, we have to calculate the trip related information. Then from the trip related information using the machine learning technique, basically the multitask learning. Okay, we are using the calculate the driver stress based on the trip related information and for the individual driver, not like the driver information one by one, because each driver have the different capability for his stress level, his or her stress level. Okay, as well as the stress level also depends on the age group. Okay, like the high age stress level is more. Okay, and that is depend on the as well as the male female thing also there. Okay, sometimes the males are the with the stress level is too high. Okay, in the case of female, the female driver stress level is too low. So like this way, then from the stress we can calculate the driver behavior, means aggressive or normal or something. Okay, so then it is here we are using the hidden Markov model or HMM. Okay, for the calculating the behavior of the driver from the stress. Then we establish the relationship from the driver stress and behavior, and finally either we recommend, not recommended, and warning some change the some message. Okay, so this is the basically our intelligent system. Okay, so any doubts, any query? This is the first one, and first one, then after that we can transmit the information. Okay, and for the next trip. So any doubts, any query up to this? Okay, okay, so here the both things is under related to the machine learning. Now, how we'll apply the machine learning and what are the information? What are the trip related information which is the related to the driver stress? Okay, and what are the how we establish the relationship with the stress to the behavior? Okay, how when the stress level is too high, then the behavior is most probably aggressive, but how we related this thing? Okay, so this is the basically whole diagram. Okay, this is our objective. And if the Ola Uber follow this type of object, this type of system, then automatically reduce the number of accidents as well as increasing the total cost or basically the benefits. Okay, so some of the existing research work is available. Okay, in the based on the some concept. Okay, they are using the multitask learning as well as the questionnaires, machine learning concept, semi-supervised learning. Okay, but their case, what is the problem? They only concentrate on the either stress or directly from the in general that the all work is based, existing work is based on the only behavior. Okay, so directly they calculate the behavior and behavior to they are taking the, but they are not concentrating on the stress thing. Okay, so in this work, so that's why their case the multiple parameter they included, and they check the okay behavior is correct. So that's why the sometimes their performance is accuracy is basically the too high. But in the realistic scenario wise, the system will research paper, it is okay, but in the real life scenario wise, it will not work. Okay, because the only the questions, and this question is sometimes the different person have the different behavior and different concept, okay, and different knowledge. Okay, so that's why the this type of thing is in the real life scenarios, and the some challenges and basically some issues are there in the real life. Okay, so that's why we are compared this thing with the existing scheme. Okay, this is the, but we are considering the stress the stress thing. Okay, and as well as the we also implemented the logic using the multitask learning. It's okay, but with some modification. Okay, multitask learning as well as the based on the mixture of expert concept. Okay, uh, so here basically we modified the number of layer, because this is the neural network based model. Okay, so inside there is the input layer, output layer, and hidden layer is there, and we also modified the number of layer, and we checked our accuracy is also high, as well as the in the case of not only the based on the data set, as well as we have collected the sum of the data set, okay, from the here the travel services, transportation services, private transportation services, and result is accuracy is more or less similar. Okay, from the online data set, but online data set basically the based on the European company and based on the some US data sets is available. And so we compare with the Indian driver as well as with the existing data set, so more or less similar. Okay, so but the accuracies on the system is under not too high, but around 95-96%. Okay, so what is our objective in this case when we have to calculate the stress level computation? First, our objective is data collection. Okay, so data collection is under there. Okay, data collection means basically the stress related data, which data is basically related to the stress. Then the feature extraction. Okay, then the stress modeling. Okay, so feature extraction, so you identify the which paper features are the related to the stress. Okay, then the stress model based on the I mentioned either multitask learning, or you can use a deep neural network, both things based on the up to you. Okay, and then the model evaluation. Then we check the accuracy of the model. Okay, or as well as we can calculate the paces and recall, both things, and then the evaluation, then finally the effectiveness using the comparison. Okay, so these are the basically concept of this type of application or this type of recommendation system. Okay, and now behavior from the stress, we calculated the stress based on this multitask learning or DNA. Okay, as well as the after the stress calculation, we can calculate the behavior. Okay, so if this driver is basically this type of behavior, okay, all these parameters, speed is too high, okay, sudden brake multiple times, then his behavior is too aggressive. Okay, and here this normal behavior person, his okay applied the all these things, but the number of time is very less. So based on this okay, based on the behavior estimation, like this way we estimated the behavior using the hidden Markov model. Okay, so we calculated this thing using the multitask learning. Okay, and behavior based on the hidden Markov model. Now we have to establish the relationship between the this behavior and stress, and we also distribute our tasks not like the single control station. So we distribute our tasks like a vehicular edge computing based concept. So here we divided into the region, and each region have the one roadside unit, or basically the this is basically the one edge device or roadside unit. Okay, and edge is responsible for the calculate the total computation for this region. Okay, n number of the car in this region. So and we divide into the model into the two part. One part is basically the local model, and this is the global model. And all these driver stress calculation steps are same for this, and this is in the basically same. Okay, So this is for the computation faster, okay, faster computation purpose. So if the information is on the only the age related, so age directly calculate the all information stress of this, okay, from the stress we generate the behavior, and from the behavior we directly recommend it, okay. So like this type of model is efficient for this application. Okay, otherwise you can consider the simple centralized concept, control center is there. Okay, so these are the basically units. Okay, now, so finally we design this type of diagram, okay, data collection model. Here the basically we have the Raspberry Pi, okay, we have the some sensors, okay, and camera. Okay, from this diagram we can from this device we can calculate this type of information, like the stress related information, okay. And this information is collecting the device and the other root related information, then we processing the all information. And for the processing purpose we are using this Raspberry Pi or microcontroller. For sensor is responsible for the collect the information, microcontroller is responsible for the computation, the processing the information, and finally recommend the which driver is on the send the information to the control center. And based on the information, control center will check, and if it is above the threshold is on the reject the trip, okay, and if the below the threshold then the accept the request, okay. And these are the two data sets are there available online, okay. And these are the basically the total number of driver also very limited, 6, okay. And out of 6 the 5 male and 1 female driver. And this is then the basically speed of the route as well as speed and direction, and age group of the driver is 20 to 50, and the speed allow the maximum and minimum this one, okay. And this data set also similar here, also the number of female driver is more, okay, and age group, and also there the different condition road type. And both we executed our experiment in the both data set as well as our collected data set in real time data set, okay. Now in the case of feature selection we have these are the information we included, okay. This is related to the stress level, number of trips. So we decided that if the number of trips is too high, there is a possibility it will affect the stress level, okay. And trip distance covered, trip time, race time. In between, if the rest, then there is a possibility to reduce the stress level, okay. So these are the congestion, road condition, nature of the roads, okay. So multiple parameter we included, so that's why the our case accuracy is on the too high, as well as the basically this thing it is realistic, okay. And we collected not from the data set is a European data set, so their road condition is totally different from the Indian road condition, their driver behavior is totally different from our behavior, our driver behavior, okay. So that's why we want to design the generalized model which is suitable for the Europe and as well as the US as well as the Asia, okay. And like the international company like the Uber, and they also accept it, okay. So now we can calculate, but initially we implement this thing based on the only this information, okay. Then in future we can extract the feature based on this also, okay, this information as well as you can include that means physiological information, okay. Some of the existing work they uses the physiological information, but in our approach we are not included the physiological information because it is then the privacy issues there, okay. So that's why we are not using this thing, okay. But some of the existing approaches model, state of art of the model, they are using this ECG, and we are using this personal information. So we are using this one trip roster information and personal information, okay. So like the experience, age, gender, and education qualification and economic condition, okay. And as well as we included this extra miscellaneous weather condition, okay, weekend or weekday. So due to the somehow some city places basically too high traffic or too low traffic, okay. So basically we consider these 3 parameters. One is on the trip roster related information. It is we prove that it is directly affect to the stress level, and then the experience, personal information, and the miscellaneous information, okay. So this is our model. Here we divide, I mentioned our layer is on the not like the simple layering concept. So each driver task specific layer. Also, we divided our neural network is and the different because deep neural network model we are using, and we are using this concept multi-gate mixture of expert multitask learning. Okay, this concept you can use the multitask learning any other model also. Okay, more or less similar type of, but you have to think the how you modify the your layer. Okay, so we have modified the layer based on the performance. Okay, so we initially divided the 36 layer, sometimes the 27 layer. Okay, and we embedding how many layers out of 50 layer, how many layers are expert layer, how many layer belongs to the embedding layer. And okay, so these are the basically the our objective, and how many layers is related to the task specific layer. Okay, so this is the our basically concept. Okay, so based on this, finally we receive the trip related features. And then in the case of model evaluation, we are using the area under curve and F measure. Okay, so area under curve is basically the accuracy matrix. Okay, and F measure also. And we compared with the existing model, they basically consider the stress and behavior. So Verma et al. Okay, so they are basically considering the stress and behavior, because in our case, stress we consider the stress and behavior. Some of the model they are only considering the behavior, and based on the behavior, their performance is little bit high. But in our model, we are considering the both, and we are considered the real life data set, okay, as well as the experimental data set, okay, based on the test bed based collection data set. Okay, and this is on the based on the our model. Okay, and system behavior related. Okay, so these are the physiological data related. Now this is on the related to the behavior. Okay, now the what is the need for our society? So society need is on the basically this application is not only benefited for the driver as well as the service provider. Okay, more profit also there. Okay, but as well as the benefited for our society. Road safety. Okay, lower stress, less accident. So this is our justification. Okay, I already gave the justification for this. Improvement in the driver behavior. If the some driver is on the like the stress level is on the nearest to the threshold, if we'll send the some alert message from the service provider, then there is a possibility he will stress reduce his stress level. Okay, in the terms of he is and the basically take the rest. Okay, taking the rest. Okay, and balance between the income and health. So we also optimize the balance. Not only the income is on the one parameter, is the important parameter for our life. Okay, as well as the health also the important parameter. So we can establish the balance between the income as well as the health. Okay, through this somehow he will reduce. I mean somehow the reduce the sum of the income. Okay, but his health condition is on the better. Okay, in future he will take the more income. Okay, he'll continue with more income. Okay, so increasing the driving quality as well as the passenger perspective and quality of the driver experience in the driving. Okay, okay, so driver feels satisfactory, happy family life, and safe for society. Okay, challenges. What are the challenges? These are the two challenges. One is the technology challenges. Second one is the social challenges. Okay, technology challenges means basically here the data sometimes the data are the sometimes the noisy data. Now we integration of the VANIT with the stress model. Okay, this integration is integrated this thing, but somehow the accuracy level is not too high. Accuracy of the stress and behavior. Okay, and as the real life fast computation is mandatory, but we don't have the fast computation capability. Okay, and scalability. If the large number of driver is there, then the scalability is in the little bit reduced. Okay, and security of the data also the concern is there. High mobility of the node. Okay, so these are the basically challenges. Due to the challenges, there is a possibility to degrade the performance of the system. Okay, social challenges means basically the personal information. Sometimes the psychological means physiological information data is under it is difficult. Okay. And conclusion. So this is our objective. In this case, the conclude this work based on the we presented the one recommended system. Okay, detect the stress level of the driver, and based on the stress and based on the current trip. Okay, and based on the features and estimate the behavior of the driver. Okay, and behavior is related to the speed and brake pattern. Okay, and sudden lane change. Okay, and then the system will provide the behavior score. Okay, from the stress we calculate the behavior score to driver and recommend the accept, reject, or compromise the trip. Okay, future work, there is a possibility. This is not for the taxi driver. Okay, we implemented this thing for the taxi services or Ola Uber services. In future, we can extend this on the private owner vehicles, as well as the recommending the driver activity helps the reduce the stress level, as well as the for the insurance companies for the risk analysis. Okay, because they also, if there is an accident will occur, then insurance company also the in the picture. Okay, so then their case also they have to their case also the sum of the losses. Okay, so somehow if we reduce this thing, then they also benefited. Okay, so they also in future we can implement the such system for their. Okay, so for their application like the insurance and risk analysis. Okay, type of the thing, analytics part. Okay, so this is basically these are the references. Okay. So another concept we implemented like the based on the stress. Okay, we previous time we calculated the behavior. Here we calculate the behavior, and behavior based on the behavior we can design the fuel efficient driving as well. Okay, so same concept, but here we establish the relationship. This thing is under basically the if the stress level is too high, then his driving pattern and speed is totally different, and due to this there is the more fuel consumption. Okay, so if we maintain the we fix the sum of the stress level is under some threshold for the stress level, then there is a possibility is the profit in the terms of less fuel consumption. Okay, so how the stress free and less fuel consumption driving is the recommendation system we implemented for the society as well. Okay, and here we are using this edge computing based concept because some computation parameter is there. Okay, and because specific region wise we can design the fuel efficient thing. Okay, and also this is we also design the something in the all this thing is related to the machine learning. Here also in the stress level you can using the multitask learning. Fuel efficiency also you can calculate based on the your means some model. Okay, like the HMM or any other model. Okay, then you finally the this recommendation system, and this is under some social networking concept. So any doubts, any query, or any feedback? Any question from the audience side?
Thank you, Dr. Dash, for your valuable presentation. And we also got the flavor of machine learning, how practically they are used in our society and actual life.
Yes, thank you, Dr. Bishankar. Okay, if any student or any participant have any query, anything?
Now the session is open for question and answer. If anyone have any query, please you can ask.
Okay, and in the chat box, I also mentioned my mail ID. So if you have in future any query, anything, so you can directly send me the mail. Okay.
Okay, so if there is no query, then we can conclude the session. And once again, thank you, Dr. Debasish, for giving this presentation from your busy schedule. And thank you.
Okay, thank you.
And all the participants will get their next session's link in their email by tomorrow.
Thank you, participant. Thank you, Debasish sir. Thank you for the wonderful lecture. Sorry, I joined late.
Okay, no issue. Thank you.
Thank you very much for your informative talk. I hope the students as well as faculty members attending the program will be very beneficial for them. So, thank you.
Okay, thank you.
For the participants, tomorrow again we'll meet at 3 p.m. We have 2 lectures tomorrow. I hope you have got the invitation links for tomorrow's. The link is same, but we have just informed the speakers. Bishanka, can we conclude for today?
Yes, Shanivar sir, we can conclude.
Okay, let's conclude for today, and let's meet tomorrow at 3. The candidates who are having Gmail IDs, I hope you have got the invitation link. So kindly join 10 minutes ahead. The speaker will join at 2:55.